All right, welcome back to the last section of chapter 1. We're going to be talking about angle pairs today, so just kind of expanding on our discussion from the last couple of days with angles. So we're going to talk about what different types of pairs you need to be able to identify. We'll talk about any special characteristics associated with those particular angle pairs, and then talk about some examples and things that you might run into as far as how to identify or work with those types of pairs. So the first thing we're going to talk about are the different types. So the first one I want to talk about is what we call adjacent angles. So adjacent angles are two angles that share a side. So I have two angles that butt up next to each other. So in the picture below here, we can see that we have angle PQR in red, and then we have angle RQS in blue. These two angles are side by side, and they share this middle chunk QR right here in orange. So when we talk about adjacent angles, that's what we mean when we say we have two angles that share a side. It means they're next to each other and they have a side in between that they share. Now what's really important here is to understand that just because two angles share a side does not automatically make them adjacent. They have to be next to each other. For instance, if I come back to this picture here and I look at the big overall angle PQS, and then I look at the smaller angle RQS here. Now, technically, they do share a side right here at QS, but that shared side isn't in between the angles. Angle RQS is on the inside of angle PQS. Those are not adjacent. So when you talk about adjacent angles, you have to be really careful. They have to be next to each other. The side they share has to be in the middle. If it doesn't have that happen, they're not adjacent. The next type is probably the most important type of angle pair, because we're going to see these over and over and over throughout the course of the year. And they're ones that after today, they're going to expect that you know, that you can identify, that you can work with, and so on. So vertical angles. Vertical angles are two angles whose sides are opposite rays. Basically, they form two straight lines. Now, the angles themselves are not the lines. Okay, so for instance, on the picture here, I have this angle here, angle 1, and then I have the angle across from it, okay, angle 3 here. Now, when I put those two angles together, you can see both pink and blue here. If I were to trace where they meet, this blue comes here and meets up with pink and forms a perfectly straight line. And then we have this pink here meeting up with blue here, forming a perfectly straight line. So together, the two angles form a straight line. The lines themselves are not the vertical angles. So it's really important that you understand when you're looking at the picture, the angles come together and form straight lines. So then I also have a pair over here that look like this. So these would also be vertical angles based on the picture here. Now, when you look at vertical angles, again, they got to have a perfectly straight line. So every time they come together, you got to have that perfect X formed right in the middle there. They're always going to be across from each other, so they cannot be next to each other. They can't be adjacent. So when we look at those, the other thing that's extremely important, and this is something that you probably want to make sure you highlight and remember for later, vertical angles are always congruent. So down in the picture here, we have this angle 1 and angle 3, which have to be exactly the same. And then we have angle 2 and angle 4, which are going to be exactly the same. So they're going to be congruent, but the picture will never have them marked for you. So typically, if I want to say two angles are congruent, I have to have the little arc symbols to tell me that that's the case. They will not tell you vertical angles are congruent. You have to understand that when you see vertical angles, they're always going to be the same. So angle 1 and angle 3 are congruent. Angle 2 and angle 4 would be congruent. So vertical angles are going to be very important to be able to identify and know their special property. Another type of angle pair that you need to be able to know or be able to identify and work with would be complementary angles. So complementary angles are any two angles that add up to 90 degrees. That's going to be the key here, because we're going to have another pair of angles here in a second that add up to something else. So 90 degrees is the key. Now there's two different scenarios that you can have. Scenario number one, you have two angles that come together and form a right angle. So I've got this angle that I highlighted in blue, this angle that I highlighted in green, and we notice from the picture that they come together and form a right angle here. So that means that right angle, total, this angle has to be 90 degrees. So these two angles together, by our angle addition postulate, have to add up to 90 degrees, and that's exactly what complementary angles are. Now that's not the only scenario that we can run into though. If you notice on the left or right side here, I've got this angle in orange, 40 degrees, and then my second angle in orange, 50 degrees. Now these angles don't share anything. They don't share a side, they don't share a vertex, they have nothing in common, but because one is 40 and one is 50, those two angles add up to equal 90 degrees, which means they are complementary. So angles can be next to each other or not. If they add up to 90 degrees, they have to be complementary angles. The next type is supplementary. So this is again where we got to be kind of careful and keep things kind of straight. Supplementary angles are any two angles that add up to 180. So here's the key here. So for supplementary, 180 total degrees. Now, just like with complementary, there's two different scenarios that occur. First, they could be two angles that have nothing to do with each other. So I have a 60-degree angle and a 120-degree angle. They don't share a side, they don't share a vertex, they don't share anything. But if I take 60 plus 20, or 120, I get 180. So if they add up to 180, they're automatically supplementary angles. So make sure you know the difference, complementary 90, supplementary 180. Now, if I were to take those two angles and put them together, so if I were to make them adjacent, which is what happens in this next scenario here, a linear pair is when we have supplementary angles that are adjacent. So that's why we highlighted these two portions right here. They're adjacent angles that add up to 180. So when you look at the picture here, we have this angle that I highlight in red, and I have another angle which I'll highlight with yellow. Now when I look at those two angles, without any information given in the problem, I know those angles have to add up to 180 degrees because when I put the red and yellow angle together, they form a perfectly straight line. And we know from previous discussions that a straight line has to be 180 total degrees. So when you see two angles come together and form one straight line, you know you have a linear pair, which is supplementary. So these two types of angles are kind of related to one another. So, quick example then, as we look at these two scenarios down below. So identify the type of angle pair below and then find the measure of the missing angle. So angle 1 and angle 2 here are two angles that we can see form a right angle, which means this big overall angle is 90 degrees, which means this is a complementary set of angles. Complementary means they add up to 90 degrees. So if I want the measure of angle 2, I simply take the total number, 90 degrees, minus the 62 I already have, and we end up with the measure we need, 28 degrees. So my complementary angles have to add up to 90 degrees. In the second example, we notice that we have two angles that come together and form a perfectly straight line. So angle 3 and angle 4 here form this perfectly straight line when they put them together, which means these are supplementary angles. And that means they're going to add up to 180. Now, because they're adjacent, I could also call this a linear pair. both descriptions would be accurate when working with these angles that we see here in the picture. So, supplementary or linear pair, this is the same type of deal where I know that the big overall angle here has to be 180 total degrees. So if I want the measure of angle 3, I take that total angle, 180, minus the 47, and I get my angle measure, 133 degrees. So knowing which type of angle pair you have will allow you to set up and solve an equation for whatever angle is missing. As far as identifying angle pairs, so it says, using the figure at right, determine if the following statements are true or false. So, angle BFD, and if we highlight that angle, BFD, so B to F to D, and the second angle, which is CFD, so I take C to F to D. Okay, so those are my two angles, the one highlighted in blue, the one highlighted in red. It says these are adjacent angles. So there's my key word right there, adjacent angles. Now for adjacent, remember, my angles need to be side by side. So when they share that side, it's got to be two separate angles that are side by side. Now when I look, these two angles do share a side right here, but that side isn't in between, which means this is a false statement. Those two angles are not adjacent because they're not side by side. Now, if I wanted to make this a true statement, so if I wanted to reword this so that I had a true statement, I could change angle BFD to angle BFC. If I trace that angle, now when I look between the light blue and the red, now their shared side is in between, these would be adjacent angles. So the original statement was false. This value that I just brought in makes this new statement true. Okay. For statement number 2, angle AFB and angle EFD are vertical angles. So if we highlight those angles, so AFB here, so A to F to B, and then the second angle is EFD. So if I highlight E to F to D. So when I start to figure out if these are vertical angles or not, remember vertical angles have to form two perfectly straight lines. So if I start tracing my pink here and I go to green, here's one where I get a perfectly straight line. So that's good. That's a good start. When I go to trace my second set, E to F, now when I go to start to go to B, I change directions. I don't form a perfectly straight line here. So what that's telling me is this is a false statement. They are not vertical angles. Okay, so again, if I wanted to change this, so I have the angles in question here. The problem was I didn't form two perfectly straight lines. So if I change this first, angle from AFB to angle AFC. So if I highlight A to F to C, and I keep the other angle like I had it, and so I do E to F to D, now if I trace my line, so I go back to my purple here, when I trace here, I get a perfectly straight line, trace here, perfectly straight line. So now I have vertical angles. Okay, so it's got to be that perfectly straight line or else they don't have vertical. For the next statement, angle AFE. So angle AFE is here. Angle EFD. So EFD here. They want to say are complementary. Now complementary means add to 90 degrees. So if I look at those two angles, I have 62 and 118. If I were to add those together, I'm definitely not going to get 90 degrees. So this would be a false statement. Now, to make this a true statement, there's a lot of different things I could do. So for instance, I could say angle AFE and EFD are supplementary because they add up to 180 degrees. So that would change that statement to a true statement. The other thing I could do is take the second angle, EFD, and I could change it to BFC. If I were to add AFE and BFC, then I would get complementary angles because those would add up to 90 degrees. So even though they're not next to each other, adding to 90 is complementary no matter what. So when you're doing these, it's important to focus on what type of angle they're looking for. And then if it's a false statement, what could I do to change it? How would I get adjacent? How would I get vertical, and so on? All right, last thing here, making conclusions from a diagram. So one of the things that's going to be important this year is being able to look at a picture and pulling out information that they don't give you. So things that you can say about the picture even though they don't specifically mark it for you, or they don't tell you in words that that's the case. So if I'm looking at this picture here, a couple of things I noticed right off the bat. First, I see these little arc symbols on angle 1 and 2. That right there tells me automatically angle 1 is congruent to angle 2. So that's something I just know based on the picture, and then I could use that, for instance, if they said like angle 2 is 30, then angle 1 would also have to be 30. So that's something that I can observe from the picture and pick up on and know right away. Some other things that I know just by looking at the picture. I noticed that angle 3 and angle 5 form those two perfectly straight lines, which means I know angle 3 and angle 5 are vertical angles. Now, not only do I know that they're vertical angles, but because they're vertical angles, I also automatically know that angle 3 must be congruent to angle 5, because vertical angles are always identical to each other. So again, they didn't put anything in the picture. If I erase my markings, they didn't tell me anything about 3 and 5. But because they're vertical angles, I know that without a doubt, those two angles have to be congruent to each other. So that's an important thing to notice. Other things that we could definitely say here. So besides that, I noticed that I have angle 3 and angle 4 here. If I highlight those angles, angle 3 and angle 4 make a nice, perfect straight line, which means angle 3 and angle 4 are supplementary. Well, what does that mean? That means the measure of angle 3 plus the measure of angle 4 has to equal 180. So they didn't tell me that in the problem. I know that just by looking at the picture. So then if they had given me something like 140 degrees here, I know angle 4 would have to be 40. Just because I know they form that straight line, I know they have to add up to 180. Not only that, we also know that 4 and 5 form a perfectly straight line. So angle 5 and angle 4 form a perfectly straight line. So in that case, those are also supplementary, which means the measure of angle 4 plus the measure of angle 5 would have to equal 180 degrees. And so when you're looking at these pictures, there's going to be times where you have to know certain characteristics. Seeing vertical angles, you have to know that they're equal. Seeing linear pair or supplementary angles, they have to add to 180. Seeing the little markings telling you that two angles are congruent. So all of those things are clues that they give you without telling you outright how to do the problem. So you have to be able to identify those things and kind of be able to figure out what's the special characteristic I need to use. With that, you should be able to complete your assignment for the day, which is the worksheet from class. So as you work on that worksheet, make sure that you ask questions if you have any questions. Make sure when the answer key comes out, you double check that answer key, so then when you turn this in, everything looks good to go. And if you have questions, you can ask in class, you can ask through email. And if you were gone in class, make sure you get this worksheet off of Google Classroom. Other than that, you should be good to go, so good luck with the worksheet.